So let's go back and have a look at the simple case of the power series. So this is our simple case of the power series. Let's make it even simpler by always making this to be equal to 1. So let's have a look at this scenario here. So let's define our function to be this series here. So when n equals 0, put it into here, x to the power 0, it will be 1. When n equals 1, put the 1 into here, that will be x to the power of 1. That's this thing here. When n equals 2, put the 2 into here. That will be x squared, and so on, all the way to infinity. Okay, so this series will give us this, and you should recognize that. Well, this here is actually a geometric series. So remember, a geometric series looks something like this. If the modulus or the common ratio is less than 1, then the whole series will converge to this value here. And you should already know this. We've seen this many times. So when the common ratio is when the modulus of the common ratio is less than 1, then the whole thing here will converge to this specific value here, this whole value here. So when you look at this here, this is actually a geometric series. Well, when x, if x is in between, if x is in between -1 and 1, then you know this whole thing here is going to converge to this thing here. So our function, so you can view our function. Our function is this thing here. This function is equal to this. But then you can always visualize it as being this function is the same as this. But the thing is, it goes all the way to infinity. Or you can imagine the function to be this thing here. So three ways of visualizing our function. Our function can be viewed as this. Our function can be viewed as this, all the way to infinity. And then, or our function can be viewed as this. So if you get a graph plotter and plot y equals this thing here, it will give you a graph. You plot a graph plotter, y equals this thing here, and then it will slowly map on top of this in the region from -1 to 1. So there are three ways of visualizing this function. Visualize as this, or as this, or as this. So now the next question is, what's the difference between this thing and this thing here, where the common ratio here is a specific number? Our common ratio here is actually x. So the question here is, what's the difference between this and this? You see, what we've got here is, hang on. So we are trying to understand the difference between this scenario and this scenario, because here we've got something that involves x. Here is something specific. It is one specific value, a third. So what we've got here is really, remember, we've got a function. A function is, remember, this is our function. A function is like a machine where you put something into the machine, into your function, and then it spits out a value. That's a function. It spits out one value. If you look at this thing here is not a function. It is one specific value. This whole thing here will spit out this value here. So this whole thing here is just a number. It is one value because it converges to this. It's just one value. Whereas this thing here is like what you've got here is like a machine. You put a number into here and it will spit out a value. Here, this thing here, it is one value. It's always one value. This thing here, if you put a number in between -1 and 1, it will spit out a value for you. So if you put in, let's say a half, it will then spit out a value for you. This thing here, it is one fixed value. This thing here is like a machine. You put in a number, and then it spits out. So this thing here, you can visualize it. You can visualize this thing here as being a machine. You can put any number into here as long as it's in between -1 and 1. So our machine only works for -1 and 1, because Because anything beyond this, let's say you put an 8 in here, it will break down. Because the whole series will diverge. You see, so what we've got here is a function. The domain for our function is between -1 and 1. So what it means is our machine here, you can only put in numbers that are between -1 and 1. So our domain for this function is between -1 and 1. So it's pointless putting the number -7 into there because the machine breaks down. What it means is the series diverge. Okay, so when you come to view this function here, what you've got here, view it as a machine where you can put a number, you can put a value of x into the machine, and then it will spit out a value. But make sure what you put into the machine is between where it will converge. This thing here is one specific case. This thing here is just a value. It's just a number. This thing here is a machine where you can put in, let's say, 0.7, and then it will spit out a value for you. So it's like a function. So this is like a function. This is one specific value. That's the difference. Okay.